Today, not only are we going to build an improved version 2.0 robot to play the Dino game on Chrome, but we're also going to beat the game, and beat it using Sonic. Stick around until the end. About 3 or 4 weeks ago, we built a small robot to play Chrome's Dino game. It's really cute. It would tap the spacebar and make the dinosaur jump over obstacles. But this little robot had several problems. There were 2 challenges we couldn't overcome with that version of the robot. The first challenge was that along the way, some low-flying pterosaurs would appear. And when at that moment, the dinosaur would bump into the pterosaur. Because at that moment, instead of jumping, the dinosaur needed to duck, but ours wouldn't. Another issue in this game is that sometimes it turns to night and everything reverses. The black dinosaur turns white, and the white background turns black, confusing the Arduino sensors. In this video, I'll fully solve these problems and take things even further. The easiest challenge is managing day and night. We just need to detect when it shifts between day and night. What did we do to solve this? I added another light-dependent resistor, another light sensor here at the end, and it's already an improved sensor. Let me turn on my second camera here, because I put a cover around the light-dependent resistor. This way, we focus solely on the light it captures. Without this cover, it picks up ambient light and other things. I also fixed how this sensor's light readings fluctuate even with the screen on. For example, it might capture 500 units at first. Then, during the game, it goes up to 530, or down to 470. In the code, I fixed it so that when the game starts, it detects the current white on the screen. During the game, it keeps updating what is considered white based on screen brightness. And then one sensor is the main one. It's used to jump over obstacles. And the other sensor is just to check if it's day or night. So this one lets you know, hey, it's night. Now the cacti you have to jump over are white. They're not black anymore, okay? The second problem we needed to solve was the pterosaurs. And then there were many comments saying that the ideal way is to always play ducked down. So I needed to press the down key, and when it's time to jump, I release the key, press the spacebar, it jumps, and then, look, it ducks down again. So it always plays ducked down so the pterosaur passes overhead. No danger. It doesn't even worry about the pterosaur anymore. We tried this with the original robot, which has 2 servo motors, one for the spacebar and one to hold down. The problem is that the Arduino isn't that fast. When you needed to jump, you had to lift the down arrow, press space, hold it for a while, then release space, and press the down key. All that movement, using a regular servo motor without a motor driver, without any special control, it just wasn't working. So, what did we do? We changed the Arduino. Yes, we swapped that Arduino Uno for an Arduino Leonardo. Funny thing is, Arduino is actually an Italian name, a real Italian person's name, and so is Leonardo. So, Arduino Leonardo, there are likely several people in Italy with that name. There are probably people in Brazil named Arduino as well. Let's take a look at the Instituto Brasileiro de Geografia e Estatística website. You can see it there, this site here. These are all the names in Brazil in 2010. It's a count they did based on the census. This isn't perfect. It might not find your name exactly in your city. Let's see if there's Ibaré first. Come on. There are 592 Ibarés in Brazil. It's a name that was much more common until the 1960s and then became less used. Rio Grande do Sul has the most Ibarés, likely due to the famous painter Iberê Camargo. I'm not sure if he was born in Rio Grande do Sul, but he lived there, and the Iberê Camargo Foundation is located there. If you're from Rio Grande do Sul, let's see Arduino. There are 330 Arduinos in Brazil. The majority were born in the 1940s, including 93 Arduinos. Most of them are in Santa Catarina, a state with many Italian immigrants. Let's return to our Arduino Leonardo. What's the advantage of this Arduino Leonardo? What it does is that it can be recognized by the computer as if it were a keyboard. Everything changes. I no longer need servo motors and can send commands directly from the Arduino to the computer. Use the spacebar or press down digitally, with no mechanical movement, eliminating what slows it down and drains the Arduino's energy. When you press the motors, the sensor would get messed up. Because you used energy running the motors, less energy would reach the sensor, and the sensor would get confused. It would read a result that was a bit off, like that, and it would lose some accuracy. We solved 3 problems: slow servo motors, pterosaurs lowering, and the day-to-night change. So, let's do a little gameplay here. I won't go into too much detail about how I did this, because if you want, you can download the code down below and you'll understand how I did this in the code. One thing that's different about the Arduino Leonardo is that it uses a micro USB cable. It's more like a cell phone connection. Cell phones are using USB-C more now, but it connects through this smaller connection here. In this project, only the 2 light-dependent resistor sensors are connected to the Arduino, and I also put a potentiometer here so we can turn off the Arduino Leonardo. I was a bit lazy, I could have used a button, but I thought it was easier to do it with the potentiometer. If you don't turn it off, it keeps controlling your keyboard. So if you switch programs, it stays here. You open Word, and it starts typing the spacebar down. It thinks you're playing the Dino game, so I always leave it off there. When I start the Dino game, I turn the potentiometer, and from then on, it starts reading the screen, and so on. The last thing, there are also 2 10 kilo ohm resistors. These resistors are used to connect here along with the light-dependent resistor sensors, right? From the light-dependent resistors, because light-dependent resistors are also resistors, so we can get a reading, okay? They're down there, in this tangled mess here. But it's basically the same thing as the previous robot, with the difference that now I have 1 more sensor, okay? One thing I haven't figured out yet is how to organize this thing. Which one is the jump sensor again? This one is the obstacle sensor. If you're watching this video to learn how to play the Dino game for the first time, the computer doesn't have to be offline to play. This message usually appears when offline, but just type Chrome, ://Dino. The no internet dinosaur pops up, but you still have internet. You just hit the spacebar. He starts running here, and then you can play, okay? And that's how I can set the position where the sensor will be. It has to be positioned so it can read the cacti here. Look, I know the cactus appears at this height, so put the sensor a little before the cactus. It will check this point on the screen to see if it darkens when the cactus passes by. And it does. I can place the background sensor anywhere else on the screen, like up here, for example. Theoretically, it's already working. The reading has started, and look, it's already working. Let's see here. Yeah, let's see. It didn't read, right? In this case, it skipped, didn't it? Let's go. It's not reading. Did I switch the sensors? Yes, I switched them. Everything's ready. Let's see if I'm not going to embarrass myself here in front of you. Just so you have an idea, the last robot got to about 500 points, okay? That's the most I could do here in this game. On my computer, at least, the counter goes up by about 10 points per second. So the longer you last in the game, it keeps counting every second. 10 points, okay? For reference, it lasted around 50 seconds. Let's see if we manage to improve that number with this robot, which has 2 sensors, controls the keyboard electronically, has an automatic light sensor, and a local sensor. I'm going to start this thing right away. When I turn it on, the little guy ducks, then jumps when it senses the cactus, but stays ducked otherwise. Oh, cute. You can see that the distance from the light-dependent resistor to the dinosaur is very important, right? Because the point where it detects the cactus is when it needs to jump. Look, it's going smoothly. Just right, just right. Oh, what a cute little creature. Now I won't cut it either, because when I cut the gameplay, people think I cheated in the game. You can watch the whole thing too. Look, one problem with this game is that it keeps getting faster. So, if what you did is kind of slow, if the Arduino is slow, if the code is slow, it starts to mess up. Look, it already reached 500 points, past the pterosaur, managed to get past the first pterosaur, which was down. Look, jumped over another pterosaur. At 700, the game turns dark. We're almost there, and at this moment, you get butterflies in your stomach, because this is when the sensor flips. Look, made it. He's playing well in the dark. The other sensor warned him, careful, everything flipped. Now, white is black, and black is white. He's jumping just right. We're already pretty much doubling the score. 900. Now it gets there quickly, but there's a problem. It jumps too high over the obstacle. There will come a time when it probably won't be able to jump. It'll hit the obstacle, but still, I don't know about you, but it gives me butterflies to watch the computer play by itself because I root for the robot. Look, 1200, it's already going really far. It's so nice when you manage to make a robot that reacts just right. 1,400 points. We pretty much tripled the number of points the little guy is able to get. You saw night and day pass. The pterosaur went by. Everything was fine. I'd probably have to add something else to the code here. So he starts speeding up and jumping faster and faster. I'll need to place the sensor a bit further forward on the screen. And at first he's slow, he jumps slowly, and then he starts jumping faster, 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 faster. But that would become a cat and mouse chase. And I'd never finish the game since he eventually gets too fast. And the light-dependent resistor, which is the little sensor, would never be able to detect that a cactus had passed. So, we decided to follow some tips that some people gave us, which were possible to do in this game. You can control some things in the game. Reading isn't exactly Arduino. It's programming, just not within Arduino. Even without an Arduino, you can do this. It's really cool. Let's dive into the heart of the game now, okay? You right-click here on top of the game screen and select Inspect. And then we can open all the game code here on the right side. Then you go to console here and type the following code. .prototype.gameover equals nothing in parentheses. Just hit enter. I'll prepare everything here so you can copy and paste like me with Control V. This way, you avoid typos. What happens when you hit enter? I'm even going to close the console window here and play again. I can play normally. Then I jump over the cactus. Oh, I jumped over this one. This one I won't see. It passed by. He no longer sees the cacti. You don't lose in the game anymore, and you keep scoring because the score is based on time. You see, it makes a plink sound whenever it hits 100 points, right? Now it'll hit 200 and make a plink again. That means we become invincible at that moment. Of course, it's not that fun to just make the character invincible. So, I'm going to do two really cool things here. The first thing is that I want to finish the game to see what happens. So, there's another command, which is to make this a little faster, okay? If it adds 10 points per second, reaching 99,999 will take 99,999 divided by 10, or 99,999 seconds. Since 1 hour is 3,600 seconds, I can calculate the time needed. I know it's going to take me 2.77 hours. Let's check how many minutes that is. 2 hours and 46 minutes for me to find out. I'm not recording all that screen time to get there. There's a trick to make time go faster. Look, I click on Inspect again here, and then it opens the console again. I go to the console again, and I enter the following code. Here, I can adjust the little guy's speed, which is usually 100. I think that's the normal speed. Let's set it to 100 and check if it runs. At 100, it's faster, but not extremely fast. Set it to 10,000. Now yes, look at the speed it's going over there. It's going to finish this really fast. When it blinks, it means it reached a number, but it's still counting time in the background. You see, it went well beyond 99,999. Maybe it'll reach 999,999. We're about to find out since there's little left. Absolutely nothing happened. We reset the game. Nothing happened. Thank you, Chrome, for adding this at the end, but that's fine. Now, let's get to my favorite part, which I found even cooler than the robot or beating the game. Which is that we can change the character that's jumping there. There, you can change all the images and fully customize the game. I'll show you how to change it by using Sonic, which was already online. I didn't make this from scratch. You right-click and inspect again, and it will open here. Look, Elements. Okay, Elements. Then you'll have to find one whose name will be Offline Resources. That is, Offline Resources. Where does Chrome store these images, right? Where is the dinosaur image stored? It's stored here. Click the arrow on the side and you'll see it right here. In this huge code, there's an image. I'm going to copy this code, go to the Chrome tab, paste the code, and this shows up. Here, these are all the images from the game. Everything that happens is shown here. If you change this, you can run the game with other images. So, some people take it and put characters from other games. What did I do? I adapted and fixed the one made for Soniku, which wasn't working well. I'll share a link below so you can download all the code. So, look, this is a Google Drive file, okay? I'm selecting everything. It's massive since all the image info is here. Look, how crazy. It puts Sonic in exactly the same position as the dinosaur. So instead of the dinosaur moving its little legs, it's Sonic. When the dinosaur ducks at the end, you can see Sonic also ducks the same way by turning into a ball. So let's put this huge code here in that place I mentioned, right here, inside these offline resources. So you notice that the image we're seeing in the game, these images, they're stored inside the game's source code. You won't be able to find a portable network graphics, a graphics interchange format, or anything like that as a file. You won't be able to find it because it's all in here. One file is inside another, okay? Let's run this to see if it turns into Sonic. The game has started. Ah, how nice. It's nighttime, but everything's fine. I messed up the whole game, made everything fast. I'm going to reset here, okay? Now I'll have a clean game with no cheating here. Normal speed. I can play with Sonic. Huh, man, look how nice. Look, crouching. Huh. How many points can I get manually without a bot? Huh. The worst part is, I'm not good at this. Look. Nearly hit the cactus. Playing Sonic on Chrome is awesome. Come on, little guy. I'm missing the rings, huh? By the way, I didn't reach 300 points. By the way, you could also change the whole background. Instead of having cacti, you could have something else. You can even copy the entire Sonic game and put yourself in it, playing with your own face if you want. So, let's do what I promised at the beginning of this video, which was to beat the game using Sonic. So, let's just go there. I forgot which code I used, so I'll copy it from my cheat sheet. So, let's beat the Dino game using Sonic. By the way, when it turns negative, it just takes the image that was there and puts it in negative. So you can see that Sonic turns yellow. It messes everything up as if it were the negative of a photograph. So the images, when it's night, they don't exist. It just takes the previous image and simply inverts the colors. And we're already almost at 500,000 views, and it played. It must be the post office delivering something I ordered for the next video. But stay with Sonic finishing the Chrome Dino game while I answer. Guys, mission accomplished. We had a lot of fun modifying the game. Even without Arduino, you can do the same. To finish then, you get to see our Sonic being played by the Arduino. What a beautiful thing. Do you think Sonic plays better than the dinosaur? He reached exactly the same point.